Cool. Alright, so I have to apologize in advance. I have more like 60 slides as opposed to 20, which these guys have had, so I'm going to fire hose a little bit. So if you get confused, please put your hand up and tell me to slow down or something. So without further ado, I'm going to be talking about Dynamo and Refinery. So we usually have the safe harbor statement whenever we present anything at Autodesk. This is, we're going to say some stuff and show some things, and please don't make purchasing decisions based on what you see today. This is more for interest and excitement and a little bit of history. So who am I? I've already introduced myself. This is me hiding because I now have to field all the hairy questions that you guys throw at me on a daily basis. But first of all, why Dynamo, and what's kind of the point of it? So Dynamo brings you value in two different kind of predominant contexts. In this case, we have the ability for Dynamo to do workflow automation. So we have here the balance or the variance between manual Revit work and Dynamo usage. So Artem Boyko, based in Germany, has this really cool little LinkedIn post, some of you might have seen it, where he showcases exactly how long it takes him to model traditionally, which takes around an hour and 2 minutes, versus running a few scripts through Dynamo Player, running down to 1 hour and 10 minutes. It's a really cool video. He does speed up the second half, so if you don't have to watch for an hour and 10 minutes or something, it's fun. And then the second premise is really around sort of computational design. It's now enabling new design potentiality inside of the traditional design paradigms you have, such as Revit. So you can now do more with a different interface and a different entry point, but also enables a different way of thinking to have different kinds of outcomes. So actually, what is Dynamo all about? It's really about uncomplicating things. So in this case, we have something such as the Thing Explainer, which tries to explain really complex things in only the 1,000 most common words in the English language. And Dynamo kind of tries to do this. So we're taking stuff which is on the left-hand side, which is, gobbledygook to many people in the room and a little bit non-gobbledygook to others, and we're converting it into stuff on the right-hand side. So we're talking about language variance. So how can we go from something that may be unintelligible on the left-hand side to something that is kind of intelligible on the right-hand side and becomes really easy once you jump in, sometimes both feet first. So if we're trying to ask the question of what is the view scale, it takes that much code on the left-hand side to do it, and it takes that many nodes on the right-hand side, which is not actually that hard or difficult. So when we get to Dynamo itself, or we get to the premise of visual programming itself, we're talking about the sort of difficulty versus capability matrix. So traditional design paradigms beyond pen and paper use direct modeling or interaction. So it's kind of like a linear process. You start something, you click a button, you do something else, and you move on to your next task. And then we have this full coding environment. So if you're aware of what an API is, which is the ability to start talking to programs and making them do things, this is kind of a lot harder, a lot more difficult, but gives you a lot more potential as well. And what sits in the middle of this is visual programming. So in the context of Autodesk, in the context of the programs that we're working with, we're talking really about Revit, which is your traditional design or modeling paradigm. We're talking about something such as the Revit API, which allows you to do a whole bunch of really cool things, especially when you string them together. And Dynamo sits in the middle as this kind of bridge between these two environments. It allows you to have some of that power of this big yellow blob at the upper corner, but allows it in a much more sort of integratable and seamless way for someone who comes from a design mindset to attack. So as visual programming is named appropriately in this kind of context, we want it to be something that enables designers to jump into this process rather than being potentially scared away by the 1,000 lines of code that you might have to write and understand. So at its most baseline principle, what is Dynamo? Dynamo is basically a series of events around reading, computing, and writing stuff. You take something, you do something to it, and then you push it back somewhere else. Simplistically, this is the base of all Dynamo graphs. They get potentially way more complicated than this, but fundamentally, this is really what is happening. So, taking a breath for a second. The community is a really big part of what makes Dynamo sort of successful and really powerful at the same time as well. So you guys are part of the community. You probably have been before today. Maybe you've just joined as of today, so welcome. The Dynamo community has almost 2 million different installs from community-created content. So Dynamo itself and the team, when we build content, we only have a certain amount of bandwidth. We can only do a certain amount of stuff. So what we've done is we've enabled an ecosystem that allows people like yourselves to create content and then ship that out through a package manager, or the ability for us to ship this out. And then anybody who wants to can consume this down at the tail end. So we have almost 1,300 different packages from the community members around the world, totaling, like I said, 2 million downloads almost. So, what is Dynamo's principles? So Dynamo is focused around being immediate. We want it to be a live programming environment where you can see what is happening at any given point in time. We want you to be able to do something and see something, see a reaction to your action. We want it to be understandable, so we want to be able to introspect this at every single stage. We don't want you to have to sort of conceptualize a whole bunch of different things in your head before you can understand what's actually happening at the tail end. We want it to be compatible. We want it to have this correlation between visual and textual coding environments. So we have the ability to have visual programming, but we also have a feature inside of Dynamo called Node to Code that can automatically turn all of that, or 90%, quote unquote, of those nodes into their textual coding variant inside of a language in Dynamo that we have called Design Script, which is the basis of our graphs. And we also want it to be extensible. So we want Dynamo to be able to connect you to existing tools and data, and really any tools and any data. So Dynamo is an open source project that allows you to take it into any other environment you wish. And we've got community-driven content created in programs way outside the Autodesk ecosystem. So to talk about that a little bit, inside the Autodesk ecosystem, we have a whole bunch of different hosts that there's somewhere where you can find Dynamo. So some of you will most likely be familiar with Dynamo for Revit. This has been the predominant sort of vehicle for Dynamo over the years. It was originally started inside of Revit and then decoupled after a couple of years. And we now sit within all of these products you see on screen, and Dynamo Sandbox being the slightly different variant here that is our own core component technology wrapped up into sort of like a playful development environment. But if you're a civil engineer in the room, Dynamo is now accessible in Civil 3D. If you want to play with sort of conceptual design applications, Dynamo is available in Format as well as I don't think we have any car designers in the room, but if you're playing with Alias and surface modeling tools, Dynamo is also accessible there, as it is in Advanced Steel. So that's kind of like a little bit of a nutshell of what is Dynamo and why. And now I'm going to go through a few examples of what it can actually do for you. So thanks to the guys who previously presented to start painting this kind of picture around what Dynamo is and what it can do. I'm going to go through about circa 5 or 6, maybe 10 different slides on things. We have workflow augmentation. So Dynamo allows you to enable much faster, much more seamless workflows. So this is a package here called Dynamaps that will bring in all of that topographical data in the space of 10 to 12 different nodes. You gain a whole bunch of power with very little input at the front, and this will allow you to pull in this OSM map data, topography, trees, roads, and so on for site context at the click of a button through an extension inside of Dynamo. Dynamo also allows for computational design. I actually tour the tables down here if you want to pass them around. So yeah, thank you. Pass them around to the room. People can have a look. This is computational design. Like I decided, about 4 or 5 years ago, that I wanted to play with designing some furniture. So I decided to make this glacial table after I found or saw something online which generated sort of a concept from this. But it allows you to create the ecosystem within which designs can ideate or formulate themselves. It's like you codify a system within which these designs can be found. In this case, you can ideate through different variants. It also allows for Revit model authoring. So in this context, this is a Snow Hitter project that plays 26,500 different Revit families, and they understood their contextual awareness as well. So we're talking about understanding the edge conditions when on the right-hand side you see the shape changes and these panels have to potentially be cut, as well as the randomization of these color modules themselves. We also have the ability to do automatically filling in complex forms or automatically doing part of your modeling process. In this case, Revit rebar. So ABT decided to do wind turbine foundation rebar and use Dynamo for it, and automatically placed a whole bunch of rebar associated with this project. We use Dynamo also as a data transfer tool. So the most basic version of this is Excel through Dynamo into Revit, but you can do this as a data interrupt tool between many different things. Rhino to Revit, Dynamo to anything, SAP 2000, Tekla, and so on. We have Dynamo as a drawing production tool. So the ability to generate sheets, automatically generate views, populate those sheets, and do a whole bunch of manual laborious tasks that become repetitive again and again at the click of a button, providing you set up that context correctly at the outset. We have the ability to do data mining. Potentially you get a project or a Revit file from somebody else and you don't really know what's in it. Maybe you want to go and mine that data to understand the fidelity or the viability of what has been modeled in the first place. So you can go through and mine a consultant's model, maybe even someone from your own firm, maybe a historical model that you've forgotten about, and understand that context of that model. We also have the ability to do shape analysis. So to cultivate understanding, we can take some complex forms and start slicing it and dissecting it to understand what we might need to do to start fabricating this form in a real-world application or situation. We also have the ability to do 3D coordination. So you do have technology such as Navisworks that you can use for this, but you can also build Dynamo graphs that start leveraging either the Navis API or direct clash detection toolkits within Revit itself to start understanding what is happening when some chosen category starts intersecting with another. So if we're talking about MEP ductwork going through walls, you can automatically understand those intersection points and automatically place not only openings in the wall but fire dampeners based on the actual fire rating of the wall itself. So we're talking contextual awareness and modeling based on that contextual awareness. And then as a way to sort of bifurcate the ability to both create and consume, we have this thing called Dynamo Player. So we've talked so far about Dynamo in terms of creation. It was mentioned by Dennis that you can also use Dynamo Player to play these things at the click of a button, and this is the way that we enable that inside of Revit. This is also going to be coming through in Civil 3D in the not too distant future as well. So this allows you to democratize graphs that you created to the rest of the people at your firm. So we're talking about the ability to say, I want to just consume this. I don't want to necessarily create it. I'm maybe a little bit scared about nodes and wires, or maybe my compatriots, my peers are. This enables them to just interface with a very simplistic, interact with a very simplistic interface and play with only some of the variables that you choose as the creator of that graph for them to manipulate. So fire hosing, sorry, again, but now that we understand a little bit about what Dynamo is, I'm going to talk about the development and what we're working on right now as a team. So first of all, the state of yesterday. The state of yesterday is what Dynamo, or what we were working over the course of the last year or so. So we were focusing on these 3 different areas, the first one being performance. So we are well aware that Dynamo needs to behave and perform better, and we're making active gains within this and have been doing so for the last year or so. So in order to enable this, we needed to build a performance harness that allows us to benchmark what is actually getting better and what is actually getting worse as we make improvements and changes to Dynamo. So we spent the better part of the first half of this year working on this harness in order to enable us to benchmark and understand the ramifications of choices that we make, and also now increase the fidelity of performance over time. We also focused on learning, so we focused on enhancing the Dynamo Primer, we focused on enhancing the video content that we have, and the ability for people to start learning Dynamo from the outset. We also focused on sharing, so if you're following along with the Dynamo blog recently, you'll notice that we're focused on this thing called the Workspace Dependency Viewer, that's just the name is changing, and this is allowing people to share graphs with more success. So we're talking about giving a graph from person A to person B and having them understand what they're missing from that graph. If they have packages or are missing packages from somebody else, they'll now be able to self-solve that problem. So in the context of what's happened in the last year or so, Dynamo has migrated from an add-on, which is kind of a subservient feature to Revit, to now as being an integrated feature inside of Revit. So we're talking about Dynamo now shipping natively inside of Revit. You no longer have to install this. Every single version of Revit, be it a generalized release or a point release, is now going to have a new version of Dynamo associated with it. So every single person in your firm no longer has to manage this crazy complex matrix of what Dynamo version you have versus what Revit version you have, because you're all going to be on the same system at the same time. In terms of learning as well, we've also started releasing public roadmaps. So in the last 3 months, we released the first one, and then around 2 weeks ago, we released the next roadmap that showcases exactly the kind of work that the team is working on right now. And the focus of this is historically been around those 3 different things I've talked about, and in the future, I'm going to showcase in a couple of slides down what we're going to work on right now and moving into next year. This is also available on our wiki page under the GitHub or Dynamo repo. So in terms of the learning content, like I just mentioned, we refreshed the learning material. So video tutorials, we have upgraded to the 2.x environment, so you should be able to go and play with these. There's 10 different videos you can now go and learn from the outset. These are available on our website, so if you just go to dynamobim.org/learn and scroll down, you'll find the video tutorials for the 2x environment. Be mindful that we also have some advanced tutorial videos, but they are for the older version of 1.x, and you might have to try and figure out 1 or 2 node differences as the software has evolved over time. We've either sort of deprecated, so removed and retired a few nodes, and also added in new ones that will be showcased in different ways. And we've also gone and updated the Dynamo Primer. So the Dynamo Primer is an e-booklet, so it's a Git book, and this has hundreds of hours if you want to jump in and do that all of Dynamo learning content right here available on our website as well. So this is just primer.dynamobim.org. If you just go to our baseline website and Google Dynamo, Dynamo BIM, sorry, it's probably Find the Magician if you just Google Dynamo, maybe Dynamo Houston, I can't remember what sports team now, anyway. You'll be able to go through from zero to hero all the way through and understand exactly from nothing all the way through to being successfully proficient within Dynamo at the very least a basic level and potentially an intermediate level if you want to start playing with some Python or some design script. And so what is some of the work we've been doing? Some of the work we've been doing is around performance. So these are the 6 different things that come into play when we're talking about performance within Dynamo. And these 6 different things you can either interact with as a member of Dynamo, a community member using Dynamo, or you can't. So the things in green are the things you can actually manipulate. These are the things you can potentially change your graph or change the settings of Dynamo to make your graph run faster. Tessellation is about the breaking up surfaces into polygons. You can change the rendering precision of that, for the rendering. You can also understand what nodes take a long time to render and not. But the things in pink are the things you can't actually do. And so this is what we are focusing on here at the team. So we're focusing on how we can make the UI interaction load up faster, how we can make the conversion between different typologies and to get very technical, the conversion between these crazy things called abstract syntax trees in the virtual machine and the way that Dynamo actually mathematically runs your graph, interpolates the results and spits it back out to you. So that being the state of play of the last year or so, this is the state of today. And this is what our team is working on right now. So we're still working on performance. This is going to be an ongoing thing. We're going to try and make Dynamo faster and faster and faster. So we are at Dynamo 2.4 release right now. We're working on Dynamo 2.5, which will be shipping in the not too distant future. And the big focus here has been on performance and stability. So we want to make Dynamo not crash as much. We want there to be less bugs, and we want it to be more performance. So it's going to serve you better, especially in the context of scalability. So Dynamo right now is a fantastic one-to-one experience. We're moving it into a place where we're going to make it a better one-to-many experience. But the scalability of Dynamo historically has been a little bit unfortunate, and so we're making this a little bit better. And we're also looking at the ability to give you tools and methodologies on how you can tune your own graphs. So we released an extension called TuneUp, which I'll talk about later, that allows you to understand how long each part of your graph is taking to run to allow you to self-help and fix that. And then we're also rounding out the sharing narrative, or the ability for you to give your graph to somebody else and have that work first time. So in terms of sharing, this is the Workspace Dependency Viewer, which is now being renamed actually as Workspace References, so apologies for that. But it allows you to get a graph from somebody else, and it'll pop up a window on the side if you're missing content and give you options on what you want to do with that content, be it completely missing to install or giving conflicts of having variants of versions. So one version's shipped with the graph and one version shipped on your machine, and you get the choice on what you want to do to self-help and fix these problems. We also have this TuneUp extension, which I briefly mentioned, the ability to sort of understand exactly on a node-by-node basis what it's taking time to execute, and so where you can actually target some changes. So potentially you have a workflow that is doing a lot of geometry stuff. If you change that to more vector-based math operations, you actually see a massive increase or decrease in the execution time and increase in the fidelity of your graph. And this tool is going to tell you how to find those kind of problem spaces to start making decisions on what you want to do to potentially reframe your graph content. We're also enabling the ability to share through the package manager. This filter is it's gone through phase 1, it's got a little bit of work to do, but we're looking to enable the ability for you to find packages faster. So we've got some work detailed on the package manager that's going to showcase to you, what is a Civil 3D package, or what is a package that contains nodes that are required from Civil 3D to run versus Revit versus all of our other flavors of hosts. And then we finally come to Dynamo, the state of tomorrow. So this is the work that we're planning and targeting to start working on early next year. And this is once again around performance. This is going to be a reoccurring theme. We want to make Dynamo scale. We're actually actively working. We did a profiling report. We had a consultant actually do this profiling report that showcased to us all of these different problems from a real world perspective of where Dynamo sits. It's understanding UI interaction lag, VM problems, scalability problems, but from real workplace problems. And we're going to surface a few different fixes over the coming months for those. We're currently consuming that content in order to target the most bang for our buck fixes that we can do that fixes the majority of problems. We're also trying to make Dynamo simpler to use. So we know that as somebody who's trying to get into Dynamo, there's a lot of jargon, there's a lot of crazy language and things that you need to cognitively understand to be able to be successful. We currently have a bunch of error messages that don't make sense. We have a bunch of different inputs and outputs that may or may not be missing. So what we're trying to do is simplify this. So right now we're doing work on taking the 30 most common error messages and making those way more easy to understand for a layperson or a designer or somebody getting into Dynamo for the first time. And they're going to surface themselves again on this sidebar panel, and it's going to give you actual steps on how to rectify those problems. So for the 30 most common at the outset, and moving into the future, we'll be adding more to those as well. And the last thing we want to do is make Dynamo smarter. So we want Dynamo to start helping you, to start suggesting to you on how to improve, on what to place next, understanding the context of what you're trying to do within your graph, and start to be more of a design partner as opposed to being something that is subservient to you as the designer. So that was Dynamo. We now have Refinery. If we want to whip through this in like 5 minutes or 10 minutes, from a very high sort of conceptual level. So traditional way of designing buildings has been pen and paper. And then we moved on to, or migrated or evolved into computerized thinking. And what we really wanted to do is encapsulate what was in these professionals' heads, what was their knowledge, and whip that through and change that into algorithmic logic. So take this professional intelligence and make it into algorithmic knowledge and embrace or find the opportunity within this space. So an example to play with this, if you've seen a presentation from me before, apologies because you're seeing this again, but NASA had an experiment back in the 1960s where they designed this antenna, and this was the most proficient and most performant antenna that they could come to after tens of years with myriad of different designers. And this was called the quadrifilia helix antenna. It was aesthetically pleasing and very performant for its day. But in 2003, NASA decided to run through a groundbreaking generative design study to try and understand this design space or this design ecosystem. And what they did is they ran through tens of thousands of different options, as you see cycling on the left-hand side of your screen right now. And they resulted in the one on the right-hand side, which was not only something the designers would have not come up with themselves, but it was actually 90% more efficient than the previous human-designed design. And so in the context of this here, we're not looking for aesthetic beauty, we're looking for performance. And so NASA found a much more performant design for their application in space. And when we're talking about this sort of relationship between computers and generative design and human beings, we're actually talking about a partnership. And so we're talking about a symbiosis between man and machine, where we have human designers as being a huge part of the process, actually propping up the front end and the back end of this process. So human has to set the concept, the constraints, the goals, has to understand the actual design problem in the first place, and they also at the tail end have to evaluate, curate, detail, and integrate that design as well. And what the computer simply does in the center is does all the heavy lifting and manually calculates things that you don't really want to spend your time doing. So in a more sort of like technical process, we're talking about the generation of options that moves through to then be analyzed using metrics. So you set up your own metrics for this. You can then rank these based on the metrics, evolve them closer towards optimality to find your evolved or optimal design, and then at the tail end the human being goes through a visualization process, or the designer, and then integrates their chosen option and finalizes the design in traditional methodology. So if you're curious about generative design, there is a Refinery primer just the same way or akin to the Dynamo primer, which is now available on refineryprimer.dynamobim.org. So if you want to play around with this, there is again chapters and chapters and chapters around concepts, sample workflows, sample toolkits to get you started on Refinery or generative design in the AEC space. So a few examples of what you could achieve with generative design. You could do program distribution, where you want to understand the trade-offs between office space versus retail space and what that gets you. You can do things such as feasibility studies at the outset. You know, what is the shape of this building going to give me versus the cost of the facade system versus the cost of the lift. If I make it taller, is it actually going to make me money? We can do site layout, we can do cut fill stuff, we can do space layout and understand proximical relationships as well, and try to find these kind of optimal designs within the space. So we set the algorithm, or we design the space within which a design itself can birth and find optimality. So we had a hackathon here in Toronto. Unfortunately, I have no images from that one, but we also ran a hackathon earlier this year in London, and these are a couple of generative examples we have from the hackathon. So on the left-hand side, we have AFL architects who design a whole bunch of different stadiums in the UK. And so they designed a system that showcased, based on the size and constraints of football pitches, what was the most optimal way to design seating. And so if you notice, the red is not ideal seating, and the blue and the green is a little bit better. On the right-hand side, we had Heatherwick Design Studio, calling themselves Hackerwick, looking to try and find beauty using Refinery, or using generative design. And so they were designing or recreating a Garden City project that they have in New York, which was around trying to understand the biggest aesthetic variance within their design space. We also had Stealthy Roofscapes, which were looking to try and generate the ability to build buildings on top of buildings. So understanding what kind of space in the London context we could build when you're not allowed to actually see that new building. So in this case, in this case we have the ability to have a visual impact score. It's going the wrong way, my bad. Let's see if that runs. We have the ability to have a visual impact score, which has to be lower because you want to see less of the building, but then you want to have the biggest volume possible to build, otherwise it's not necessarily viable or profitable to do so. And on the right hand side, we actually have the winners of the hackathon in London, which was a team of people who had never met each other before, coming from a myriad of different backgrounds, and they built an application that tracked the metrics or analytics of Dynamo usage across firms, offices, geolocations on a per run basis, and spat that out to Google Data Studio, and allowed you to then visualize all that data to understand who is using what graph at what time, what were the graphs you wanted to invest more time and effort into versus what are the graphs you wanted to understand why people potentially weren't using. So when we get to some more sort of conceptual level things around generative design, a couple of use cases that we have done here at Autodesk. At the University Exhibit Hall in 2007, we used generative design, gold around two different things, buzz and exposure. We also did this exact building that you guys are sitting in right now, so the levels above, 2 and 3, were designed using generative design as well, and gold around 6 different things. We'll talk about that in a second. And there's also a project called Van Wynen. So if you guys have been around Autodesk for a while, you might have heard of this name, and they were golding around a whole bunch of other criteria here, and they included profit and cost into this mix as well. So the generative design space for this specific office here was based on metrics gained and gathered in the old office in Toronto for Autodesk. So this was understanding things such as like, what is low distraction, what is adjacency preference, interconnectivity, what are all these results that we want to get from this design space. We had 6 of them associated here on the spider diagram on the right side, and this was done through metrics, through surveys, understanding the existing space in order to elicit an understanding of what means a good design or a better design in the new space that we have here. And so this is just the tail end of one of the studies done by the Autodesk research team, which are involved with the Living, an architectural project we have, team we have here at Autodesk, that showcases how we went involved and explored these design systems inside of this office space. So we're talking about thousands and thousands and thousands of different designs, which no human being wants to ever pass through themselves, tear your hair out. But you can use the system of metrics and ranking and analysis to then pull through the most unique or most useful designs from this. And in this context, we pulled through 10 or so different designs to then take from sort of a humanistic design point further down the piece, which results in the office space we have above. But from like a more 3D perspective, we are looking for a bespoke solution that understands the exact constraints of what our office staff and colleagues wanted. So we're talking about the ability to understand the variance of neighborhoods, the variance of office space, so seating arrangements for desks versus office rooms and so on. And we're aggregating all of these down into different numbers that we can then understand through ranking an overall score or an overall metric associated with them, and get this through both a numbers-based perspective, a visual-based perspective, and also a spider diagram to quickly hone in on what is relevant to us at any given point in time. And if you guys are curious about this and you're starting on your Dynamo journey as well, we actually have this project graph available right now. It's called Project Rediscover by Autodesk Research, and I can't spell, so apologies for the spelling. But you can find this on keemw.com. Keem Walmsley works for Autodesk. He's one of the guys involved very heavily with this. He's a really cool blog as well. And so to finish it up, I've got 2 different examples, and sorry for the drastic overtime presentation, but this is an example now of how Refinery is now surfacing itself inside of Revit. So as of AU, circa 2 weeks ago, we're now showcasing what Refinery is moving into. So you can still get Refinery inside of Dynamo, and always will be able to, but we're also surfacing the ability to start understanding Dynamo or Refinery akin to Dynamo Player inside of Revit. So if you have designers in your office who don't want to understand Dynamo, and you have computational designers who want to build some algorithmic logic for them to play with, they can now use this interface and never touch Dynamo themselves, but they can leverage the power of it and start making informed design choices with it. So in the context of what you see on the screen right now, we have a desk layout optimization. And on the second video here, we now showcase the same kind of workflow in the same kind of environment. And this is talking about a lighting layer. So we're trying to find the optimal spread of lights. So we want to have a lower cost, we want to have a certain level of light saturation across the entire set, and we don't want to have too much overlap in this as well. So we go through, we select something in Revit, it's interactable, it understands based on the room context, the fidelity of that room, it can pull in data associated with that room, and it's going to go and place a whole bunch of different lights, and then optimize those relationships based on your goal constraints. So it's going to design a whole series of random ones at the outset, and then it's going to take those through and towards optimality again and again through an evolutionary process. So really, what is the potential to finish up of what generative design offers? It offers expansion, a new tool in the toolkit of the designer. It offers the ability to augment. So it leverages the powers of the computer to do the heavy lifting. No longer do we want to do manual laborious tasks again and again and again. We want to use the computer in a symbiosis-based format to work with us, not for us. And it also allows acceleration. So we can do faster design iteration at the outset of a project to make better, more informed decisions for our clients and for ourselves. And at the final end, it offers collaboration as well. It allows for stakeholders to be involved in the process at the outset as well. Through this new interface, you can allow a designer, a PM, somebody in your office, or the owner to come and start making some of these design decisions with you, as opposed to waiting for you to produce something first. So without further ado, any Q&A, or are we done? Thank you.